Tell whether each of the following is true for all sets A and B. If false, then give a counterexample. For part A, it says that A union empty set, meaning that this means that all the elements in A or all the elements in the empty set is equal to A. So for part A, it says, is that true for all sets A and B? Now we're going to select the correct choice below, and if necessary, fill in the answer box to complete your choice. Well, this is true because it'll be true for all sets A and B. So let's go ahead and check our answer. There's our result. Now the second part is asking us, it says that is the set difference from A to B equal to the set difference from B to A true for all sets A and B? And then select the correct choice below, and if necessary, fill in the box to complete your choice. So first we're going to write this out as a counterexample. So we're going to let the counterexample, we're going to let set A equal ABC, and we're going to let set B equal AB. Now let's first take a look at this first side here, the equal sign. Okay, set difference of A to B is the set of all elements that are in A that are not in B. So if you take a look at set A and set B, the one element that's in A that is not in B is C. So we would say the following. We would say that the set difference from A to B is C. Now we want to take a look at the set difference from B to A. So the set difference from B to A is the set of all elements that are in B that are not in A. So are there any elements that are in B that are not in A? Well, the answer is no. So therefore that represents the empty set. So we would say that the following. We would say that the set difference for those two are not equal to each other. So let's go ahead and go back and answer here. Okay, so it's not true because we're going to say that in the counterexample, in this case, the set difference of A to B is C, and we know that the set difference from B to A is the empty set, so therefore that is our result. Okay, now let's go to question C. It's saying that is the complement of A intersection B equal to A, or the complement of A intersection the complement of B true for all sets of A and B, and then select the correct choice below, and if necessary, fill in the answer boxes to complete your choice. Okay, so first thing is first. As a counterexample, we're going to let the universal set be U, which is equal to A, B, and C. And we're going to let A equal the element A, the set A, and the B is going to be the set B. So you can see here that we have A has an element of A, B has an element of lowercase b. In the universal set, we have C out here. So the first thing is we want to first define what is the complement of A intersection B. Okay, now first and foremost, this is what we would say. We would say this is the set of all elements that are not common to both A and B. Now, this also means the following. We can define this as all the elements that are not in A union the elements that are not in B. So we can define this now as the set of all elements common to both the complement of A or the complement of B. So now we need to find the complement of A. Well, the complement of A is the set of all elements that are not in A. So all the elements that are not in A is going to be B and C. And then the complement of B is going to be the set of all elements that are not in B, which would be A and C. So let's go ahead and review that again. So all the elements that are not in A are going to be B and C. And all the elements that are not in B are going to be A and C. So now we want to be able to find the union of those two. So that means that all the elements, we want to find all the elements that are common to both A and B is going to be all of these, A, B, and C. Okay. Now, let's take a look at the right side. Okay, now we're looking at the complement of A intersection the complement of B. Okay, so first and foremost, this is defined as the set of all elements common to both the complement of A and the complement of B. So recall that the complement of A is the set of all elements that are not in A, and the complement of B is a set of all elements that are not in B. So remember that the complement of A is going to be B and C, and the complement of B is going to be A and C. And so now we want to find out, okay, what is the intersection of these two sets? Meaning, what do they have in common? So therefore, we know what they have in common is the letter C. So can we say that this is equal to that? Well, no. Therefore, it's not equal to that. So now let's go ahead and then answer our questions. So over here, we're going to do the following. If we look at D, it'll say that no, it is not true for all sets in A and B. As a counterexample, let the universal set be A, B, C. We're going to let A, the set A, be the element A. Set B be the element B. That's the only difference between C and D, is that B is equal to element B. So what do we determine was the complement? Well, the complement was A, B, and C. So we have A, comma, B, comma, C. Okay, and then what was the intersection of not A and not B? Well, that was the letter C. And therefore we know it's not equal to. So check our answer, and there is our result. Okay, now let's go to D. It says now, is A union B, or the set difference of A union B to A, equal to B, true or false for all sets of A and B? So let's go ahead and take a look here. So as a counterexample, okay, we're going to let set A be AB, and we're going to let B be the set B. So first and foremost, we're going to do the following. A union B is the set of all elements that are in A or B, and we know that the set A is just AB. So let's go ahead and write this out. So what are all the elements in A and B? Well, we know it's going to be A and B. So A union B is equal to the set AB. And we know that set A is equal to AB. So what is the set difference? Well, now the set difference of A union B to A is the set of all elements that are in A union B that are not in A. Well, we don't have anything that's not in that set for that set. So therefore, that's going to be the empty set. Okay, now we need to compare this to set B. Well, the empty set is not equal to the element of B. So therefore, this is not the same as B. So we would say that we have the following, that they're not equal to each other. So let's go ahead and fill in our result. So it's not true. Okay, and let's see here. We know that we have the following. We're going to let A equal AB, and we're going to let B equal B. So in this case, we know that this is the empty set, and this is not the same as B. So this is going to be C. Okay, now let's go to E. It says, is the set difference of A to B union set A, is that equal to the set difference from A to B union the set difference from B to A? So let's go ahead and do that. So as a counterexample, we're going to let set A equal A, B, and C, and we're going to let set B equal C, D, and E. Now the first thing is first. We have the set difference from A to B union A. Okay, well, we know the following. We know that this is defined as the set of all elements that are in A that are not in B. So what are all the elements that are in A that are not in set B? Well, all the elements that are in set A that are not in B are going to be AB. So the set difference from A to B is going to equal the elements AB. Now we also need to take a look at set A. Well, set A is A, B, and C. And so now what does this stand for? Well, this is saying that it is the set of all elements that are in the set difference of A to B or in set A. Well, if you notice, they have an A, B, and C, so therefore all of those are going to equal A, B, and C. Okay, now we need to take a look at this other side here. Okay, so we want to find out what is the set difference from A to B union the set difference from B to A. So let's take a look at the definition. This definition states that it is the set of all elements that are in A that are not in B. So we know that all the elements that are in A that are not in B is AB. And then this definition is the set of all elements that are in B that are not in A. So what are the elements that are in B that are not in A? Well, it's DE. So therefore, the set difference from B to A is DE. So now we want to find out the definition here. So this represents the set of all elements that are in the set difference from A to B or in the set difference from B to A. So that means we're going to have A, B, D, and then E. So therefore, we would see that that represents A, B, D, E. Now we need to determine, are these two sets equal to each other? Well, they are not, so they are not equal to each other. Now let's go ahead and answer our question. So we know it's not true for all sets, right? And so we know that we chose A, B, C, and C, D, E. And so we know that the first one that we got, which was the union, was ABC. So therefore, this is A, comma, B, comma, C. And then over here, we said that that was A, B, D, E. So A, B, D, and E. And let's just confirm that. So we have A, B, D, and E. And then we also know that they're not equal to each other. So let's check our answer. And that is our result. So it's important to understand the definition of each piece of the following statements.